Assalamualaikum and good day. We are team from UTM would like to present
Project entitled Development of Automated Hydroponic System using Solar Energy and Artificial Intelligence for Agriculture. Here is our team members. Hydroponic agriculture enables healthy crop production. In response to address the hydroponic challenges like poor reliability and accuracy, inefficient tracking like water use, and lack of energy solar for sustainability with the goal of developing an AI-driven system for real-time monitoring and sustainable crop growth using solar energy and mobile integration. This system aims to enhance IoT-based automated hydroponic system with AI and mesh networks for improved efficiency while integrating solar panels for sustainable energy usage. Here show the flowchart and block diagram system design featuring solar panels, ESP32 nodes and a Raspberry Pi 5 in a mesh network to monitor water levels and crop data. It is to ensure redundancy, alert notification, automated water pump activation and predictive analysis for optimized hydroponic performance. This section highlights the hardware setup. Pictures 1 and 4 show ESP32 nodes with ultrasonic and water level sensors in a mesh network. Picture 2 displays the Raspberry Pi for AI functionality. Picture 5 illustrates the solar energy system and picture 3 also includes the smart plug for remote pump control. Here shows the result for the software part of Blink monitoring interface where the graph model accurately predicts crop height from water level with 94% test accuracy and minimal errors. The project is aligned specifically with SDG 20 Hunger for fostering sustainable food production system and SDG 7 affordable and clean energy through the integration of solar panels for renewable energy use in agriculture. This slide summarizes the projects from 4 perspectives. The main benefit is easy access to crop health information for farmers, enhanced farming efficiency with IoT mesh networks for reliable connectivity in its uniqueness. A solar-powered automated hydroponic system with AI for optimized growth and resource use is also its usefulness, and strong commercialization potential supporting digital transformation and RR 4.0 in agriculture as shown by the graphs. The project first added value showed the MOU between university and the respective NGO. This extended project also has been awarded with a copyright from my IPO. The project also has been published in international journal.
Good morning everyone, my name is Chris and my project title is Development of Automated Hydroponic System using Solar Panel and Artificial Intelligence. I am going to explain about how I make this hydroponic setup look smart and autonomous. There are 3 buckets here. These 3 buckets contain one ESP32 nodes each. So as you can see here, there is a ESP32 node which connected to the Wi-Fi and connected to the ultrasonic sensor and a water level sensor. So these 3 devices are connected into the mesh topology. Mesh topology is a wireless connection which connects to each devices and transfers its data which will store into each devices. These data are collected for upcoming use for the prediction model, which the prediction model will use these data to predict the future of the growth by using the 2 variables which are the crop height and the water level. So as you can see, here is the ultrasonic sensor. The ultrasonic sensor is a sensor which sends the signal to the object it's nearby to measure the height of the object. So here I use the ultrasonic sensor to measure the height of the crop. And the next sensor is the water level sensor. As the name mentioned itself, the water level sensor measures the water level in this tube. Next, the connection between the ESP32 nodes and the Raspberry Pi. I connect the Raspberry Pi here to collect all the data which are collected from the ESP32 and the sensors, sent directly to the Raspberry Pi for the saving purpose. So this protocol is the MQTT protocol. This MQTT protocol, which means the lightweight messaging protocol, will help to store the data which are collected in the ESP to save at the Raspberry Pi. Now I want to explain about the main power source. So in this case, I mentioned earlier, I am going to use a sustainable energy power, which is the solar energy. So in this case, this is the solar panel which I use to convert the sunlight to DC current which stores in the battery. So as you can see here, there is the battery which stores the power, and also this is the white box which is the Raspberry Pi. This is the solar charge controller which controls the power which supplies from the solar panel to the battery. And this is the DC to AC converter which converts the DC power in the battery to AC and supplies the voltage to the every devices which I connected here. Now I'm going to explain about the blink application, which I use to monitor the real-time water level and the crop height. So as you can see here, this is the blink app that I used. So here you can see the water level. I can see the water level which are through the every tube, so that I can monitor the water level, and so that if the water is low or no water inside the tube, I can on the tank. As you can see, this is the smart plug which is connected to the tank. I use an app called Smart Life app, which will be like this, on off button here. So if I on here, the pump will on automatically. So this feature helps me to on and off the pump anywhere and anytime. So this is the coding which I configured into the ESP32 nodes to measure the crop height and the water level. So as you can see here, the node 3 is functioning here by measuring the variables, and also they are communicating each other with the other ESP nodes like this, like received from this node, received from this node. So as you can see here, every node is measuring their variables and sending the data each other, so that it will store into the each ESP nodes as well. So this is the coding which I configure in the Raspberry Pi Python PIPY to for the MQTT protocol. And later on, the CSV file will be used to do the prediction model.
So let's run the Python script pipy. So as you can see, the connection between the subscribers and the publishers are successful. As you can see here, we can see the message topics that are collected, which are the three ESP nodes are collected data as shown in this display, which are published here. Okay, so now let's say if the node 2 is not functioning or it's in a system down position. Okay, so when the node 2 is temporarily down, as you can see here, the node 1 and 3 as well, they are still releasing their data, they are publishing their data still on the display. And the node 2 results are not shown in this display. So we can assume that, we can conclude that the Raspberry Pi, the main subscriber, hasn't received any data from the node 2 because of the issue it encounters. So all the ESP nodes have to be always on so that it can publish the data to the MQTT protocol. So after this, these values will be converted to a CSV file for the prediction model.
CSV file is imported to the MATLAB for the regression learner to generate the prediction. So here I plot the graph using the find 3 digit, which is the decision 3 prediction model, to evaluate the prediction model. So as you can see here, this is the original value which was converted from the CSV file. And this is the predicted value after we import the values to the prediction model. So the variables are crop height and the water level. So this is the summary. Based on the summary, these are the test results. As you can see, the when the RMSE value, which is the root mean square value, in a low value, which means the predicted values are better accuracy. So the RQ value, which is a 0.81, indicates the 81% of the factor is the affects the growth of the crops, which is the water level. So remaining to 19% are factors from the other factors. So the MSC value and MSA value, mean square error and the mean absolute error. When both of them are low, which means the predicted value is nearly corrected to the actual value. For the NAE, which means the differentiate between the predicted and the actual crop. So that is the prediction model. And I'm also import all the values into the neural network to check whether which prediction model is better to predict the future future of the crop heights. So as you can see here, the decision tree, which is the find tree, makes the better choice for the crop heights.